Today's video starts on page 1 of your 5D packet, Exponents and Functions, Unit 5D, Functions Continued. So you can see this is a problem of the day page. Please do this page on your own, the entire page, and we will go over that in class. Remember, M equals and B equals before you go to graph. So the next page, page 2, comparing two functions. The table shows two functions relating the distance traveled, y miles, and the time taken, x hours, of objects A and B. Use a verbal description to compare the two functions. So they've started it for us here. And I'm looking at both of these functions. I can see that my slope in object A is up 3 and over 1, right? Up 3 and over 1, up 3 and over 1. So I have a delta y over delta x of 3 over 1. In object B's travel time, it's up 1 and over 1. Up 1 and the y value, change in the x is 1. 1 and 1. So delta y over delta x in object B is 1. So they are both increasing, and they are linear because they have a constant rate of change. So they are linear increasing functions with an initial output value of 3, because if I go down 1 here, I'm going to be at 0, 3. And if I go down 3 here, I'm going to be, and down 1 there, I'm going to be at 0, 3. So they have an initial output value of 3 with an input value of 0. When x is 0, y is 3. The function for object A has a greater, right, because it's 3 over 1, rate of change, a greater rate of change, that's your slope, than the function for object B. Write an algebraic equation to represent each function. Well, y equals mx plus b. We know in object A, m is 3, and b is, oh, I figured it out. I figured out that it's 0, 3. So my y equals mx plus b is y equals 3x plus 3. My object B, my slope was 1, and my initial value again was 0, 3. So that's my y-intercept. So this one is y equals x, 1x, kind of silly, plus 3. Which of the two objects, A and B, move at a slower speed? Well, comparing the rates of change for the two objects, object B has the least rate of change of 1, right? So object B moves at a slower speed. Next page. Two machines, M and N, shred large sheets of dough into spaghetti noodles. Yum. The table shows two functions relating the total amount of dough, y sheets, and the time taken, t seconds, to process the dough sheets into spaghetti. Use a verbal description to compare the two functions. Okay, well, I've got to figure out again. This looks like it's going up 5 and up 1, up 5 and up 1, up 5 and up 1. So my slope is 5 over 1, or just 5. Oh, no. My slope is delta y. Ooh, delta y is 1 over 5 over delta x. Ooh, upside down. So my slope is 1/5. M equals 1/5 here. And it looks like in N, we're going up by 3's, right? On the y value, and we are going up by 5's on the x. So delta y over delta x here is 3 over 5. So m equals 3/5. So a greater rate of change here with machine M. And if I was to go down 5, I'd be at 0 when x is 0. Okay, so I'd be at 0, 0, and going down 1, right? And if I go down 3, I'm going to be at 0, and down 5, I'm going to be at 0. So they both start at 0, 0. Use a verbal description to compare these two functions. Well, both of them are increasing. My slopes aren't negative, so they are linear because they have a constant rate of change. So they are linear increasing functions with an initial output value of 0 and a corresponding input value of 0. So there's my y-intercept, 0. The function for machine n has a greater rate of change, a greater slope. 3/5 is greater than 1/5. Oops, graders. So it's greater than machine m. Write an algebraic equation to represent each function. Well, we know we write it in the y equals mx plus b form. Our slope for machine m is 1/5. X, well, plus 0, we're not going to write that, or y-intercept, right? So m here was 1/5, and m here, the slope is, or the rate of change, which is our slope, is 3/5. So this would be y equals 3/5 x plus 0. We don't write plus 0. Which of the two machines, m and n, is able to process the dough sheets into the spaghetti faster? Well, machine m is. Machine n has a greater rate of change, 3/5, right? Greater rate of change, which we call slope. So it will be able to process dough sheets into spaghetti faster than machine, spell that correctly, I was going to skip the N, than machine M. Next page. Compare two different linear functions. I think this whole entire page is already filled out for you. They're showing linear increasing functions. So this is a good notes page. You can read this one on your own. So read this page. Go ahead and stop the video and read this page on your own. It's a good example already filled in. Next page. So juice packets. Two dispensers contain two brands of juice, juice A and juice B. They were sold in packets at a baseball game. The amount of juice remaining in the dispenser, Y liters, is a function of X, the number of packets of juice sold. So here they didn't give us two tables. They gave us a table for A and an equation for B. Write an algebraic equation to represent the linear function for juice A. Well, my delta Y looks like it's going down 300. Is that constant X? Oh, yes, it's going up 2. So we do have a constant. It is linear. It does say it's a linear function anyway. So my delta Y over delta X, my slope, the change in the Y values, is going to be negative 300 over 2, or negative 150. So my equation for linear A would be, I'm going to pick a point and solve it for y equals mx plus b to figure out, right, my b. So I know my slope is negative 150. So the point that I'm going to use is 1800, that first point given to me. So y equals, the y is 1800, we can put that in. 1800 equals negative 150 times 2 plus b. So I'm going to add, because that equals negative 300, I'm going to add 300 to both sides. And I get 2100 equals my b, because that's going to cancel. So my equation then is y equals negative 150x plus 2100. Use a verbal description to compare these two functions. Both functions are decreasing. That's a negative rate of change, negative 200. And this one has a negative 150. So they are decreasing. I'm not going to put that on here. Decreasing linear functions. Comparing the two equations, because 2100 is greater than 2000, the dispenser containing juice A has more juice at first, but comparing the rates of change shows that every packet of juice A contains 150 liters of juice, and every packet of juice B had, what was the rate? 200 liters of juice. So more juice B, because it's decreasing faster, is sold than juice A. Next page. Heather regularly saves the money she earns babysitting. If she puts the money she earns in a piggy bank, her mother gives her a certain amount of money. If she puts the money she earns into her bank account, the bank gives her with a certain amount of money. The bank gives her with that doesn't make sense. The total amount of money that she has, y dollars, is a function of the amount of money that she saves, x dollars. So let's see. Piggy bank going up by 2s and going up by 1s. So if I go down by 2 and down by 1, I'm at 0 and 20. So now I know my y-intercept there for piggy bank. And savings put in a bank account, the minimum sum is $15, and she earns $1.50 times every dollar that she saves. Write an algebraic equation to represent each function. Well, the piggy bank, PB, is, my slope is 2 over 1. So y equals mx plus b would be y equals 2x plus 20. For the savings bank, I would say y equals 1.5 times every dollar, so 1.5x plus 15. So I've given you the two linear equations. I want you, just like in the last 3 or 4 examples, to fill in part B and C. And we'll go over that with the problem of the day. And that's it for today's video.